Welcome to this Cimatron webinar. My name is Michael and I work in tech support for Cimatron. This webinar is going to cover runners and gates. We're going to look at the commands and we're also going to look at some techniques to improve your use of the commands. At any point during the webinar, please put any questions in the chat and we will answer them at the end of the presentation. You can see I have a core block and 3 sketches that I'm going to use to create runners. I'm going to start in the center with my runner part active and select project, pick that first sketch and pick the faces on the core that I want to project that curve onto. I can remove or keep that curve and I'll say OK. Next I'm going to go to runner bodies, curve selected, I'll middle button. Now you can see the different profiles I can use to create my runner. I'll select the circular or full round, and no matter what profile you use, it's just a matter of filling out the variables that they are showing you. In this case, I'm going to fill out A and B. I'm going to hit apply so I can see it before I get out of the command. If it looks good, I'll OK it. Next, we're looking at, you can have a revolved end or flat ends. Typically we want a revolved end, but in another example we'll be using the flat end option. And then with the revolved end you also have options about if you want the radius to be at the end of the curve on edge on tip, or the center of the radius to be at the tip of the curve. I don't like to sketch a curve and then have to worry about the taking the radius into consideration, so typically I use edge on tip. The last option that we're going to look at is cold wells. So it added them to the end of the cross runner, but the short ones do not have a cold well. So I can select under option 2 cold well. You could have a auto length that you predefine in preferences, or I can have it on manual, and then I can select the X's here to add the cold wells on the end of the short runners. Again, they're manual, so I can, control them how I want. Once I'm good with it, I can say OK. Each one of these runners are independent or individual right now. I'm going to merge them. And now they're one. Couple options for cutting the runners in. I could use solid cut, do it to the core, do another solid cut to the cavity, or I can utilize cut by runner. I'm going to go cut by runner. It allows me to display any other components that the runner is running across. And in the command I can pick all those components, in this case the core and the cavity, middle button, select the runner. And one other option here is, it says don't create curve. I can create a curve, which I'll let it do. And that curve can be used for machining the runner in if you didn't want to use the surface data. So depending on, again, how you program or how you machine, if you didn't use the actual data and just wanted the curves, you can see that all the curves are made. Or if you needed them for mold flow, same idea. I don't want the curves, so I'm going to edit and say don't create curves, say OK. Okay, next situation we're going to look at is going up a vertical face. That has caused a lot of issues for people to not end up using the runner command. We will start like we did last time by projecting that curve, picking the faces, say OK. I will go into the runner bodies, curve selected. We will use the trap. I can give it the sizes I want. So A and B, included angle of 10, and then a radius. Right. Now the issue that people come across is what you're seeing here, where the profile looks good at the top, looks good over here, but the transition is what's the issue. So instead of not using the command at all, I'm going to utilize it as much as I can to minimize the work I have. And what the issue is that this rad and this rad is what's causing the problem. If I edit my project and I unselect those two faces, I now have a curve that looks like this, and I can go to runner bodies, again fill out my sizes, take a look, and you can see that it handled those three separate sections no problem. The one thing I'm going to do here, again to utilize the strength of the command, is I'm going to, instead of revolved, go to flat and say OK. And now my only issue is what I'm going to do in these areas. So basically to get from this runner to this runner, I'm going to use solid loft. Solid loft allows me to pick two faces, with option 1 being to add tangency to complete that runner. Okay. Now I can add some rads or rounds. And now I can merge it together. And I have one continuous runner now. And again, I can use the cut by runner. Turn that guy off, and you can see that nice consistent depth and flow between all those different sections. The last situation we're going to look at is I want a full round runner, but I'm going across a heavily angled face that's going to cause me undercuts. So let's create the round runner to start with and see the situation that we get when using a full round runner in this area. Okay, and then I can do a cut by runner. I'm just going to cut the one side for our needs, just to show you what we're trying to avoid. And you can see that one side has an undercut, the other side is good. Okay. Quite simply, it's just geometry of cutting that hemisphere or that diameter on an angle. Part of it is going to have to go undercut. The other side will be open. So what we do to get past this, again, utilizing the command rather than, working hard, is we will, again, pick that curve. This time I'm going to use the parabolic. And, sorry, 0.375, 0.375, and we'll make this angle extremely small. All I want to do is to make sure it's not undercut. Okay, I make that runner. I look at it, you can see that it didn't come up high enough. So I'm simply going to go extend. Linear and up. Let's go 0.1. Okay, that looks good enough. Okay, and again I'll bring back this curve. And this first one we made was for the core. The second runner we're going to make will end up being for the cavity. And again, the same values. Same included angle. Difference is going to be I'm going to flip the arrow so it's now on this side. And I'll say OK to that. And while this is here, I'm going to go cut my runner. Make sure I pick the right one. And let's hide this guy. Oops, make that active. And let's hide the core block. And again, I'm just going to do a solid extend. Okay, turn this guy on, say cut by runner. And now if I do a analysis, I can see that that is open. This is all open. And the same thing on the core. And again, flip the arrow. And I see this is all open. Okay. The one thing I will show you that's the compromise for it being open is let's drag that over a bit. There we go. As you will end up with a slight overlap of the runner. But again, that's the trade-off dealing with the way that the surface bisects the diameter. Okay. Now we're going to look at gate design. My runner part's active again. We're going to go into mold design, gate design. We're going to start with an edge gate and different options we can pick. I'm going to go point and direction. I'm going to pick the center of the runner. And right now it's looking for active faces for the gate to go towards. And the active faces, the attributes translated to the faces using cut active. Center of spine just shows it'll be half in the core, half in the cavity. If I flip that to bottom, it'll be all in the cavity. And in our case, I want it all in the core, so I'll say top. You can have a draft angle if you wanted on the sides of the gate, or no draft, again depending what you want there. And now I can fill out the blue for the beginning. And make that the same width as the runner. And then the front part. And now I can make the length of that. If I wanted it the same as a runner, I could, or if I want it more of a fan gate, I can make it wider. I'm going to pull this back because I want to have a nice land. So let's pull that back 80 thou. Actually, I didn't put a minus in front, so let's key in the proper to pull it back. We can say yes. You can see it's not going all the way through the faces. So I'm just going to do an extend object on that top 10 thou. And we're good there. I'm going to do a solid extend to get my gate into the part. And I'll make sure that it breaks all the way through. Looks good. And add it to the gate itself. Turn off the core. I can add some rounds. Add some rounds. Variable. And that, and the other side. Okay, so that's our edge gate. You can see it looks pretty good. Moving on, we're going to do a tunnel gate. And again, mold design, gate design, tunnel gate. We're going to use the point and direction again. I'm going to pick the center. So again, it's looking for active faces. The angle's too steep to hit the rib. So I'm going to change that. You can also see that this is on top of spine. I want it in the middle. I'd also like it to be circular. And with this as a fan, so it's using the start diameter, I give it an angle, it'll make the back part. Again, in my case, I prefer to go by diameters, a little more control. And 375. Right now you can see it's a squared off end. If I wanted it round, it would add a ball on the end. In my case, I don't want that. Squared off. And whoops, you can see that it's right at the center, breaks through nice. Okay, so that is tunnel gate. Also, if I want, I can increase the back end to make sure when I cut the gate in, it washes out nice. I'm going to do another tunnel gate, just with a different option. And in this case, instead of using point and direction, I'm going to use selected curve. Again, change this to diameter, 0.375. And if I look at the side view, you can see that because my line went past the ejector pin hole, it's a little too deep. So I can just simply pull it back 10 thou, and now it hits right where I'd like it to hit. Okay, so that's by curve. We're going to look at another gate. And this one's going to be the curve tunnel gate, otherwise known as a cashew gate or a banana gate. Change that to by diameter. And I'm going to use 2 points. So I'm going to pick the center of the runner, the midpoint of this, and now it's sensing based on my entry angle. Hit the part. Again, I'll adjust the diameters here. And what I want there. And you can see it's a little shallow, but again, we can change that by changing the entry angle. So now it's you can see the arc is getting tighter. Try that. And once I get the arc I like, I can say OK. I want to back this off because I want to build my vestige into my part. And I can say OK to that. I'm going to use Sketcher to build my vestige. I want to get a reference point at center of geometry of this face. And now I can pick a diameter, extrude that, make sure it hits through the part, add some taper to it, whatever you wanted. And I can also now, if I don't like where this is hitting per se, I could use my vector and move it a little to get it into a better position. I'm going to add it to this, and then I'm going to add a round. That's not behaving right, so let's go here, there, and there. And we'll say OK to that. And there I have a nice cashew gate with a pretty strong vestige that should break nice and clean. The next one we're going to look at is a cashew gate. This time it's going across these angled faces. I'm going to select cashew gate by diameter. Again, 2 points. And I made this curve ahead of time, so I'd be able to define the point. Again, you can see it remembers some of the variables here. In this case, I want it to be a rectangular. If I wanted it to be in the cavity for whatever reason, even the tunnel gate, I could flip that and it would go the other side. Okay. Going to make some adjustment to sizes. Okay. And again, I pulled it back 80 thou. So we're going to say OK to that. Going to add some rounds. And I'm going to go back to the first one. Go back to the first one here and update that. Okay, I'm going to rotate this gate so that it is closer to parallel with the bottom of my part. Something like that. We're going to build our vestige again on top of here, again using the center geometry to get a center point. Adding a rectangle. Sizing this. Sizing this. And now I'm going to rotate it. Radial array. Okay, so right about there, or yeah, it's probably better. And I'll say OK. And now I can extrude that guy until he breaks through. Let's go a little bit deeper and add some taper till I'm pretty happy with it. Again, I'm going to add it to this guy. And the last thing I'm going to do is I'm going to rotate this guy by. Now he's a little more. Yeah, something like that. I'm going to add a round. All good. And rounds. And there we go. Last gate we're going to look at would be used for a 3-plate. And that would be a direct gate. So I'm just going to go point and direction again. I'm going to pick the center point. So this could be used for a 3-plate, or it could be used for a prototype where you don't have a screw bushing. Again, when I went point and direction, it found the active faces. Again, I'm going to change that to diameters, 0.75, maybe 0.25, something like that. And then, just like I did with the cashew gate, I can back this off. And then I would create my vestige on the end of that into my part. This is option 2 for that gate that's on an angled face where the part edge is on an angle. And I don't want to create a pocket that needs 5-axis to cut the inserts for it for the gate. So what I'm going to do, or what I have done, is I've made a plane that's parallel to this face. I've offset it 80 thou. And now I'm just going to do a solid cut. Say OK to that. Just going to do a remove and extend for this little piece here. Okay, now at this point I'm going to sketcher. I'm going to pick that plane. Actually, I'm going to make it in the part area, and I'm going to size it to what I want. So my actual gate size. And now I can rotate this guy a bit till it's pretty parallel to the part. At this point I can do an extrude, and I want to make sure the vector's in the direction I want. I'm going to go down to this face, and now I can take this and start angling it to how I want. So let's go like 240, and back him off just a bit. We'll say OK. We want some draft on there. And I can say OK to that. Forgot one thing, to add it to my runner. And we'll add some rounds. So that's all good. This and this. And that's all good. So again, that's another way we can do that cashew gate on this angled face. Again, we've got a nice constant land, and we can insert it like we normally would. That wraps up our webinar for today. You can visit our website at www.cimatron.com. If you're in North America, you can contact us at support-us@cimatron.com. And if you'd like to contact us by phone, you can reach us at 877-596-9700, extension 1.